This is a talk on data visualization and SQL, but it's also fairly heretical. These are my favorite talks to give. I'm Barrett Clark, at Barrett Clark on both Twitter and GitHub, and I work at the Container Store. And yes, we have been playing with containerization. Sidebar, actually, my previous job was at Sabre, big travel company, and I worked in the lab, so I got to experiment with stuff, and so I did a bunch with containerization, and actually had lunch. My team had lunch with the developers at the Container Store, and we did a knowledge exchange, what we've been playing with, and now I'm there. So Ruby is my home language. Oh, my job at the Container Store is to write Ruby, mentor in Ruby, evangelize Ruby and POSTGRES, and so that's what I do. Ruby is my home language. I've done Ruby for about a decade. It's not the only language that I enjoy writing, but it is what I consider my home language. This talk is written from the perspective of a Rubyist writing Rails, but I think that it's applicable really in any ORM context. But just so that we all know, this is a talk I've given at RailsConf. That is my perspective in this talk. So let me just see a show of hands. Who would consider themselves an application developer as opposed to, say, a DBA or something like that, app developers? OK, right on. So just a level set recap on what is an ORM. It's just a way to translate tables and rows from relational data to an object. It's this magic thing that kind of sits in the middle. So your ORM handles the connection details and the basics of your CRUD operations, create, read, update, delete. And it tries to allow your application to be database agnostic. And so as such, it doesn't expose some of the deeper database functionality that maybe isn't present across all databases. So in Rails, we have active record, which implements the active record pattern. That's our ORM. But like I said, I think this is applicable in any ORM. And an active record in Rails is a great place to start. It'll handle most of your data access needs. I do, perhaps controversially, maintain that at some point you'll outgrow active record, you'll outgrow your ORM, and you'll feel boxed in or limited, at least in areas. And so this is where I start to go to raw SQL. For example, things like complicated joins. So looking at the Rails documentation, this is how we express a nested join in active record. And I can tell you, I've looked at this a lot. I know exactly what's going on, but I really don't have any idea what's going on. So I don't know about you, but this is a lot easier. These 5 lines are a lot easier to look at a glance, to reason about, to understand, and certainly a lot easier for me to write. And like I said, your ORM handles the basics of your CRUD operations, but our databases can do so much more. And I encourage you, application developer, I encourage you to use them. And so that's what we're going to talk about today. And maybe that makes you a little bit uncomfortable because one of the promises of the ORM is database portability. Maybe? No. No, it didn't work like that. So who here has migrated in an application from one database platform to another, right? Yeah, was it easy? No, it was not easy. Database portability is a pipe dream. Well, why is that? Well, different databases are different, obviously, right? You've got different data types. You've got different indexing schemes. You've got different performance considerations. And it takes a lot of work just to migrate the data from one thing to another. And that's even between major versions of the same database sometimes. I worked at AOL a while ago, and we ran on Sybase, and I did an upgrade from one major version, from two major versions of Sybase. We did our due diligence. We worked it out, and we were still on call for a month afterwards. It was just a mess. I think replication was the challenge there. But anyways, databases are different. You chose your database for a reason, or somebody chose it for a reason. Let's assume you know what you were doing. Use your database. So some caveats. As you're going to start writing more complicated queries, some caveats. Pay attention to your long-running queries. If you're in the database for 500 milliseconds, especially in like a web application or something, that is forever long. Do not spend 500 milliseconds in the database. And pay attention to your connection pool. Don't starve your application because you've got some big fat report running in the background and all of a sudden nobody can use your website. Okay? So let's get our hands dirty. The first thing I want to talk about is window functions. And I love window functions. They're awesome. We have window functions in a few different databases, but today we're going to talk about the Postgres flavored window functions. We're at a Postgres conference. The Postgres documentation, I think, is pretty good as far as documentation goes, technical documentation. So the way a window function is defined is we're going to perform a calculation across a set of rows that are somehow related to the current row. We're going to do a calculation across a set of rows as they're related to the current row. So does that make sense? We're doing a calculation. We're going to go across some number of rows, and it's going to relate to this row, and then it's going to relate to this row. Okay? So in other words, we're going to fold data from other rows into this row. So that's the Barrett-Clark simplified documentation. We have probably a dozen, I think, window functions in Postgres, but these are my 5 favorite. These are my top 5 window functions. Lead, lag, first value, last value, and row number. Now, row number and rank are similar but different. We're going to talk about row number. We're going to take some simple data. We're going to play with it a little bit. So first, we're going to select splat, lead ID over open paren, close paren, and we're going to select lag ID. That over open paren, close paren, don't worry about that quite yet. That just means don't do anything funny with the window, with the data. We're going to just look at the entire table as it relates to that current row. And so lead is the next ID, lag is the previous ID. So as we step through the table, we can see for the first record, ID 1, the next ID is 2. There is no previous ID, that's null. We keep going, second record, the lead ID is 3, previous ID is 1, all the way down to that last record where there is no next ID, so that's null, and your previous ID is 9. Okay? Lead and lag, next and previous. So as you can see, we're going to perform that calculation across a set of rows. In this case, it was the next row or the previous row as it relates to that current row. So each row, we're going to do that calculation, and we're going to do the look ahead or look behind. Now we can do other things with that window. We can get more specific, and so that's what we're going to talk about next. We need to partition our fruit. So in this query, we're going to partition the table by fruit. So we're going to select ID fruit, then first value of ID over partition by fruit, order by ID. So what we're going to do is we're going to take that table and we're going to chunk it up by the values in that fruit field. So all the apples are going to go together. The banana, all the bananas go together, and then all the pears go together. And then we can ask, well, what's the first occurrence of the ID among all the apples? And what's the first occurrence of the ID among all the bananas and among all the pears? So we get 1 for apple. If we were asking about last ID, that would be 5. We get 10 for banana. The last ID, again, would be 10. And then pear, first time it happens is at record ID 4. The last ID would be 9. So there we've chunked the table up, partitioned it by the value of that fruit field. So given the set of X, what's the first occurrence or what's the last occurrence? We round out our top 5 with row number, and that just gives us that row's position within the partition, within the window. And you can see there each We have two window functions. They each get their own window definition. They can be different. If for whatever reason you needed them to be different, they can be. So for each row, that window is computed across the set of rows as it relates. So all the apples are together, the banana, the pear. And you can see there are 4 apples, so that row number is 1, 2, 3, 4. Banana, there's only one of them, 1. And then pear, again, 1, 2, 3, 4, 5. So that fruit, we're probably not ever going to have a table that just has 10 records in it and 3 different values, right? So let's look at something that's a little bit more practical, and everybody wants to make a chat app, so let's make a chat app. So we've got this chat data. We have 2 rooms, and we have 2 people. And so what we want to do is we want to look at those chats by room, and we want it to be your typical messaging application that just says, when Barrett says stuff, we'll say Barrett's name and then all the things that Barrett says. And then somebody else will say something and we'll show their name. But we don't need to see my name for every comment that I made. So how would we do that? Well, we could ask the database to do a look ahead or a look behind and see at what point does that user ID change. And when the current user ID and that previous user ID are different, then we know it's a different person and we need to go find their name. So I'll select ID message, room ID, user ID, and then lag user ID. So we'll do a look back. And we'll partition the data by rooms because we only care about room 1, and then we only care about room 2. So we could pull all the data down and ask our application to do all of this for us, but it would probably require some loops, maybe some nested loops, and that's a lot of work. I don't really want to do that. And the database can do it for me. And the results look like this. I added that dotted line in there to separate the 2 rooms out. That wouldn't actually obviously be in your results. But you can see our first person is leaving for the airport, and then they landed, and wow. And then somebody else came in and said, hello. Meanwhile, in a separate room, that first person was waiting for an Uber. That order by room ID isn't entirely necessary. It just was a matter of form. So an additional pro tip here, you see those order by 3, 1. You can order by and group by field positional numbers. And that's particularly handy when you have a calculated field value. I'm not ordering by that lag, which would be the 5th field, but I could. So then it would be order by 5, 1 if I were to do that. So that's not related to window functions. That's just an added little tidbit if you didn't already know that. This is how we would execute that raw SQL in Active Record in a Rails application. So this is a message model that inherits from Active Record base. And you can see we set this to the SQL variable. That's the syntax for what's called the here doc. And then we just send that SQL into Active Record base connection execute. And what we'll get back is an array of message objects that have the results from this query. Now, Active Record does a lot of magic. It introspects your table to see what the fields are and what their data types are. And so it adds all of those attributes to your model for you and does all the typecasting for you when you get the results back. In this particular case, that lag user ID is not an attribute that's hung off of this model. And so if you were to inspect that object, you would not see it. But the data is there and it is usable. If that's too anti-pattern for you, if having calculated fields that are not part of the model in the result set is too anti-pattern for you in a Rails app, we can take another approach. We can just use the PG gem directly. Now, Rails is handling the connection details for us, so if we're going directly at the database, we need to handle the connection ourselves. But this highlights how we could use a database in a Ruby application without Active Record. It's pretty simple. So we do our connection execute, we get the values back, and so instead of getting an array of objects, of message objects, we'll get back an array of arrays with a message with the field name and value in each one of those array values. And so we then have access to the data and we can move on. It's going to come out all as all strings, and so if you needed to convert to an integer or a date or whatever, you would have to do that on your own. Rails is going to handle that for you, but we're going around Rails here. So this is how we would access the database directly. No big deal. As a reminder, your models do not have to be backed by active record or even persisted in the database. You can have business logic in a model, and that is totally okay. So questions that we can now answer: when did something change? Like, when did somebody leave? How long were people in what places? So we can do enter, exit, and change events really easily. Again, we could pull all that transactional data down. We could ask our application to munge it for us. But it's a lot of work. We're going to create a lot of objects that need to be garbage collected, and we're going to generate a lot of log that we don't really need to generate, taking up disk space. All right. So another place where I like to go to raw SQL is subqueries. And these are also a lot of fun. We can use subqueries in Postgres in 3 ways: to filter and group. We can calculate a field value with a subquery. And you can also use a subquery in a join. But today, we're only going to talk about the first 2 bullets. So we're going to filter and group, and then we're going to calculate a field value. So to filter results, we need to start with a base query first. And so this will be our starting point. And in this query, we're going to see how phones move around in an area covered with Bluetooth beacons, BLE beacons. These particular beacons follow the iBeacon standard. So they communicate a UUID, a major number, and a minor number. That major number is the group of beacons, so you could consider that like a building or an airport terminal, or I don't know, however you would want to group beacons. And then the minor is the specific beacon within that grouping. So it would be a room or an area of a building, or maybe an airport gate, or the counter at a department store, or something like that. So we're going to see for a given phone, pull in that next minor, because we want to see what changed. When did they change from one area to another? So here's that query, now acting as a subquery. You can see we name our subqueries. So select all that stuff as beacon readings lead. And then we'll wrap that in an outer query that will select from the results of that inner query and say, when the minor and the next minor are different, we will just get those results. Piece of cake. So I put a query in your query. So now we can see how people moved around in the building, which areas did they move from and to, and how often did those changes occur. And the data looks like this. And I've broken the rooms up with those dashes so we can just marvel at that spectacular tabular data. It's really pretty amazing. I mean, who doesn't love tabular data, right? But really, this is how we would look at this data. This is a chord diagram, one of my favorite visualizations. And all those little swoopy lines are called chords. And the thickness of the chord indicates how big that connection is, how strong, how many times that thing happened. And the color, whichever going from and to, so whichever end has the bigger origin is which end gets the color. And then you can see, so in this particular case, looking over there on the green side and the lobby, a lot of people started in the lobby, but not very many of them went to the bar. And maybe we're in a hotel and we want to emphasize a particular drink special or something like that, and we have not done a good job with that, right? And we can see by this data that we need to do a better job of that, and so now we can spend money accordingly or whatever. So the chord diagram is a great way to show how things are connected. So we're writing our subqueries, and we're filtering and grouping, and then we're filtering and grouping, and we're filtering and grouping, and maybe you end up with this Russian doll effect where you've got subqueries that are 3 or 4 layers deep. And that doesn't feel very good, right? So we can refactor that using common table expression, CTE. These are also known as a with query. So we take this query where we had that filtering, and we can rewrite it without the nesting, like that. And it's not very spectacular. We just moved that subquery up a little bit. It's the same number of lines, but so we can say with name subquery as, and then the subquery, and then down there in the bottom half, we select from that again as if it were a table. Like I said, this example here isn't all that spectacular. Where CTE really shines is the fact that we can have little bitty bite-sized pieces of composable query that we can build up. And so what this big wall of SQL does is build up time series data and puts it in hourly buckets so that we can build a heat map and we can see where people are and how long were they in which places. Now, sometimes a base query might get used a lot. We have all these really little specific bite-sized pieces, and maybe a couple of those, or maybe the starting gets used a lot, and so we can refactor again. And we'll put that in a view, which is just a query stored in the database. It's not a stored procedure, it's not a stored function, it's just a query stored in the database. And as far as your ORM is concerned, it looks like a read-only table, which is great. We can access this easily in Active Record or Hibernate or whatever. This is the syntax. This is just SQL. Create or replace. That or replace is optional, but it's a good idea. You want to use that. And then the name of the view as, and then the query. That or replace is going to save you because as you're playing around with it, and then you put it in to an Active Record migration, let's say, if that view already exists because you were doing it on the console and then you run the migration, you won't throw a big error. So Active Record migrations, in my opinion, this is like the single biggest killer feature of Rails is Active Record migrations. It's a fantastic way to manage our database. A lot of Active Record migrations are reversible, which means Active Record and Rails understand how to create and how to remove the thing. So Active Record knows how to create a table and how to drop a table. It doesn't know how to create and drop a view, so we have to tell it specifically how to do those things. So we have in the up method, we have the create or replace. And then in the down method, we have the drop view if exists. That if exists is optional, but also is a good idea. And recently, Thoughtbot came out with a gem called Scenic, which also helps with views and materialized views. So now we can just select from that view. We don't have the top half of the CTE. And this is much nicer to look at, right? But maybe you're a little bit freaked out because now we've got business logic in the database, and that's bad, right? I know I have fought that battle in past lives as well. I'm not saying put all of your business logic in the database. I'm saying you're the boss of your code. You get to decide where and why your code runs. So talk it over with your peers, talk it over with your team. You get to be the boss of your code. Okay, so we're cruising along. We're doing all this work, but maybe we're spending 500 milliseconds in the database. And you remember Barrett said that's bad, so let's fix that. We're going to do the heavy lifting in a separate process. So we can run a query and store its results in the database, and then just query that. And that's called the materialized view. So you've got the query stored in the database, and you've materialized its data as well, persisted the data. Again, as far as your ORM is concerned, that's a read-only table, and it can be indexed, which is fantastic. So this is how we do that. Create materialized view, and you can see here I'm selecting from the view that we've already created, but I'm only taking a 24-hour slice out of that data. And then I'm adding 3 indexes to it. Now, we do not have create or replace with a materialized view because we've already got that, we've persisted the data, and if we changed a column or changed somehow the specification, it wouldn't know how to reconcile that, or at least not yet. So if we wanted to change the specification of the query, we would need to drop the materialized view and then recreate it. So we materialized this data, and we got fresh, hot data, and it's spectacular. But that's a one-shot thing. We have to update it manually if we need fresh data, if we need to keep getting fresh data. But not to worry, Refresh Materialized View has your back. And starting in 9.4, we got the ability to refresh concurrently, so you didn't just do a table lock while you were refreshing the materialized view. It will still lock on individual records, obviously, but you can be selecting against the materialized view while it's updating. And we can put this in a rake task in a Ruby application and run it on cron, or if we're using Heroku, we can use the Heroku scheduler, update it every 10 minutes. Bob's your uncle. All right. So then subquery for a field value. This is also pretty cool. So here, I'm going to select ID, phone, and then subquery. And what I'm doing here is I'm doing a look ahead to find a record for an exit event. Minor equals 0 is how I indicated that somebody left the building. So we can look at all of the records in a session. And you can see we're pulling data from that materialized view. We're selecting from it twice. We're aliasing it in the main query so that we can use that in that subquery for that filtering. We're doing all this so we can build up this sunburst visualization so we can show how people moved. So starting in the middle, we can see all the different rooms and then how they fanned out, how people fanned out through the building. I use D3 for all these visualizations. So on the website, imagine you've got mouse over events and it's all, labels are showing up and colors are dimming and it's spectacular. All right, so other general Postgres useful things. How do you get Postgres? Well, you can install it from source if you wanted. You can install it from a package manager, either apt or homebrew on OS 10 or Mac OS. If you're on a Mac, you can use Heroku's Postgres app and get the most current version of Postgres, 9.6.1, and the most current version of PostGIS for free without having to do any extra installation. The dependencies for PostGIS are pretty big and kind of a pain to deal with, at least with Homebrew. And so I would definitely go the Postgres app route on OS 10. It's not quite as bad on Ubuntu. It's actually pretty nice on Ubuntu. We've got some GUI tools, pgadmin3, and now we have pgadmin4, which is very different. Those are open source and run cross-platform. And Navicat is more of an enterprise-y software. I say enterprise-y, but it's good. And they have free trials. I like them both, and you've also got PSQL for the command line. I use all three, or I guess 4. I've been playing around with pgadmin4. I'm not sure I like it yet. Hopefully none of you in this room have worked on that. Visual query planning. So I talked about performance. We should all be keeping an eye on how our queries are performing, explain, analyze, to show how the query engine wants to optimize the query. But looking at the wall of output, that text that it generates, that's a lot of stuff to parse through and make sense of. So we can put that into one of these visual query plans and see at a glance where are the hotspots. So this one's been around for a while, and this is still my favorite. So this is a great way to see where are your biggest hotspots in your query plan. There's a tree view flavored that came out, it's been a couple of years now. A little harder to see the hotspots, but probably an easier way to just see the execution path. So depending on what you want to do, we have a couple of different ways to visualize our query plans. But a word of caution, different environments are different. So your development environment, the data is very different. You're running on different hardware. Your pgconf is very different. So your query plan on localhost is going to be very different than your query plan on your staging or your production machines. Even if you've copied that data down, it will still probably be somewhat different. So just keep that in mind. If you can afford to have a staging environment that replicates the data in your production environment, that would be amazing. If you like to read documentation to see what cool things exist, Ruby's enumerable is fantastic, so definitely check that out. But also Postgres data types. The array data type is kind of handy. So you can have an array of strings or integers. And HStore really just sort of, I think, built off of the array data type as well. Date range and timestamp range, you don't have to juggle separate start and end date fields. You can put those into this one field, and Postgres knows how to index that, and Postgres knows how to query that. We have special query operators for the date range and timestamp range fields. So it's a lot easier to deal with. And you can still have separate start and end date fields, but why not use the range? JSON, and then starting in 9.4, we got a binary representation of JSON. Anytime I hit a remote API, I will just store the entire payload in the database. Why not? Disks are cheap, and I can always clean it up later. I'll pick specific fields out, but I'll also just store the whole payload. It's really easy to query. Postgres knows how to index it. It's a good data type. And UUID, I believe it lowercases the UUID, so if you're doing a string comparison, be aware of that. But you can also use UUID as your primary key instead of like an auto increment field. And we can tell Rails, we can configure Rails such that it will use UUID as the primary key scheme. So data types, good stuff. Starting in 9.5, we got upsert. And then just recently in 9.6, parallel sequential scans, hooray. Work has already started on 10.0, so who knows what sort of amazing things lay in the future for us. So dig into your database and its functionality. Future you will thank you. Be kind to future you and be kind to your future counterparts. So as a recap, it's okay to write SQL. I probably don't have to tell this room that, but it is okay to write SQL. When I refactor, I like to start with common table expression for, instead of subqueries, for filtering and grouping. I'll take commonly used things and put them in a view. And when I need to squeeze some performance out, I'll look for the materialized view. I'm not saying do everything in the database, but the more you know, expand your toolbox. There are lots of great databases, and Postgres is one of them. And I've written this book, Data Visualization Toolkit. So if data visualization or GIS are your thing, or you want them to be your thing, then I would love to talk with you. There's a whole section on GIS and mapping and stuff. I use Leaflet mainly for that. So thank you. If you have any questions, come on down. If you want to talk about stuff, that'd be great. But that's all I've got.